Are you tired of paying top dollar for power banks that barely last a year? What if I told you that you could build your own high-capacity battery bank for next to nothing, using old laptop batteries and a few basic tools? Yep, I'm talking about a DIY project that's budget-friendly, technical enough to geek out over, and incredibly useful whether you're going off-grid, prepping for emergencies, or just looking to charge your phone 10 times on a single trip. Today, we're diving deep into the world of DIY battery banks using reclaimed lithium-ion cells. I'm going to walk you through everything, from sourcing the batteries to assembling the pack, safety tips, and even adding USB ports to charge your gadgets like a pro. So grab your gloves and goggles, because this isn't just some lazy Sunday project. It's a full-on engineering adventure that will save you money and teach you something powerful, literally. Let's get into it. Why use reclaimed batteries? First things first, why even bother with reclaimed batteries when you can just buy a power bank on Amazon? Well, there's a big difference between buying something and understanding something. Reclaimed lithium-ion batteries, especially 18,650 cells from old laptops, are often still in great shape. Most people toss laptops when the battery pack starts acting up, but in many cases, only a couple of the cells are bad. The rest, still strong and capable. By harvesting these cells, not only are you saving money, and I mean serious money, you're also reducing e-waste. That's good for your wallet and the planet. A new high-capacity power bank might cost you $100. Building your own from reclaimed parts? Maybe $20, $30, if that. And that's not even considering the performance boost you can get by choosing exactly which cells to include and how to configure them. Plus, there's the satisfaction factor. Once you build your own power bank, you'll never look at store-bought models the same way again. Trust me, it's empowering, educational, and way cooler to say, yeah, I built that myself. Where is the source reclaimed cells? Okay, so you're sold on the idea. Now where do you get these magical, budget-saving lithium cells? One word: laptops. Dead laptops, old battery packs, they're gold mines. You can find them at recycling centers, local e-waste events, thrift stores, or even by asking around in tech communities. Some computer repair shops even have dead batteries they're willing to part with for free. Once you've got your hands on a few old laptop batteries, you'll want to carefully crack them open. And I mean carefully, to remove the 18,650 cells inside. Use plastic tools or wear gloves to avoid shorting anything. These battery packs often have a plastic shell protecting a cluster of 6 to 9 cells. It's like opening a treasure chest, except instead of gold doubloons, you get lithium power. Pro tip: focus on name brand batteries from laptops like Dell, HP, or Lenovo. These often contain high-quality Samsung, LG, or Panasonic cells. All reliable choices for your build. And hey, it's kind of addictive. Once you start harvesting these little energy pods, you'll see potential in every scrap battery you come across. Testing the cells? Now comes the most important step: testing. Not all reclaimed batteries are equal, and using a bad cell can ruin your entire pack, or worse, create a fire hazard. Before you even think about assembling anything, every single cell needs to be tested for voltage, internal resistance, and capacity. Start by measuring the voltage with a multimeter. If the cell is below 2.5 volts, there's a good chance it's been over-discharged and is no longer safe to use. Anything between 3.5 and 4.2 volts is generally good. Then you check the internal resistance using a tool like the Opus BTC 3100 or a specialized internal resistance tester. Lower resistance usually means a healthier cell, but the real test is capacity. Charge each cell fully, then discharge it through a tester to see how many milliamp hours it can still hold. This step takes time, hours per cell, but it's crucial. You're building a power bank, not a ticking time bomb. It might sound tedious, but this phase separates the rookies from the serious builders. Think of it as the quality control department of your own miniature energy factory. Series versus parallel. Once you've selected the good cells, it's time to design your bank. Here's where you get to decide how much power you want and how you want it delivered. This is where terms like series and parallel come into play. When you connect cells in parallel, you're increasing the capacity, more milliamp hours, meaning your bank lasts longer. When you connect them in series, you're increasing the voltage. For example, three 18,650s in series give you around 11.1 V combined series and parallel, and you've got flexibility. A common DIY setup is a 3S3P configuration, 3 cells in series and 3 groups in parallel for a total of 9 cells. You can scale this up or down depending on your needs. Want to charge a phone for days? Go big on capacity. Need to run a 12V LED setup for camping? Match your output accordingly. And don't forget to balance the cells. You want cells with similar capacity and voltage levels in each group. Mixing a strong cell with a weak one will always bring down the performance, and that's just a waste of your hard-earned reclaimed power. The heart of your system. Okay, you've got your layout, but raw power isn't enough. You need control. That's where the battery management system, or BMS, comes in. This tiny circuit board is the brains of your build. It monitors the voltage of each cell, manages charging and discharging, and most importantly, it prevents your battery pack from overheating, overcharging, or short-circuiting. Choosing the right BMS depends on your configuration. If you've built a 3S battery pack, get a 3S BMS. There are plenty of affordable models available online. Just make sure the BMS supports the discharge current your devices require. If you're just charging phones, a 5A to 10A BMS should do. But for heavier loads, like running a small inverter or powering tools, go with 20A or higher. Installing the BMS is straightforward. Wire it to each series group and connect it to your output terminals. Most BMS boards also have dedicated charging input pads for connecting to a solar panel or DC charger. Without a BMS, your battery pack is a liability. With one, it's a smart, self-regulating energy source. Make it look good. This is where you go from backyard engineer to mad scientist with style. Your battery bank needs a solid enclosure, not just for safety, but for durability and looks. A lot of DIYers use 3D printed cases, ammo boxes, or even modified plastic toolboxes. The point is to keep the cells secure, the wiring clean, and everything shockproof and waterproof if possible. Inside, you'll need proper insulation between cell grooves, ideally with heat shrink tubing and padding. Outside, you can install USB ports, DC jacks, or even 120V outlets if you're adding an inverter. Want to get fancy? Add a voltmeter display, a charging indicator, or even a toggle switch with a glowing LED ring. This step is where your build gets personal. You're not just making something functional, you're building your own energy solution. Whether you're prepping for a blackout or just tired of carrying 6 different chargers on your next road trip, this bank will be your trusty sidekick. And when someone asks, "Where'd you buy that?" you get to smile and say, "I didn't." Charging your DI power bank. Alright, so your battery bank is ready, but how you actually charge it? You've got a few options. The simplest is to use a compatible lithium charger that matches your series setup. For example, a 12.6V charger for a 3S pack. These are easy to find and relatively cheap. You can also get creative. Want to go green? Hook up a small solar charge controller and feed in power from a solar panel. Prefer speed? Use a regulated DC power supply for faster charging. The key here is to always charge through the BMS, not directly to the cells. The BMS will regulate the current and protect the cells during the process. And don't forget to monitor your first few charges. Feel the pack. Watch for heat. Make sure the voltage across each group is balanced. Once you're confident everything's stable, your battery bank is officially ready for the wild. From road trips to power outages, you now have a custom-built high-capacity energy source, and you made it from scraps. Why this matters? Now you might be thinking, okay, this is cool, but what am I actually going to use this for? Great question. Your DIE battery bank has tons of real-world applications. Going camping, you've got a reliable way to charge phones, LED lanterns, fans, and GPS devices. Living off-grid or in an area with unstable power, your bank becomes a backup power supply for lights and radios. You can even power small home projects, Raspberry Pi builds, or security systems. Want to go bigger? Connect your DIY pack to an inverter and run a laptop or even a mini fridge during an outage. And it doesn't stop there. Once you've mastered the basics, you can scale up. Build a second bank. Add solar. Upgrade to Life 8P04. You're now in control of your own energy. There's a reason preppers, dyers, van lifers, and tech hobbyists love building these. It's about independence, reliability, and the satisfaction of solving real problems with your own hands. So there you have it, a full DIE battery bank, built from reclaimed laptop cells, custom wired, and ready to power your world. Not only did you save money, you learned some legit electrical engineering skills in the process. That's a win-win-win. If this video lit up your curiosity, hit that like button. If you're ready to try this yourself, or have any questions about testing cells or choosing a BMS, drop a comment below. I read them all. And hey, if you do build your own power bank, tag me or send a picture. I'd love to feature some of your projects in a future video. This is just the beginning. Energy independence starts with one cell, and you just reclaimed it. Thanks for watching. Stay charged up, and I'll catch you in the next one.